Okay, so today we're doing dot plots, stem and leaf graphs. So the dot plots, we sort of seen them yesterday when we were looking at histograms, because remember when we click on our list, it automatically created dot plots anyway. Okay, so we saw the dot plot. So a histogram and stem and leaf plot below represent the same set of data. They show scores achieved by a class in an exam. So you can see here, we've looked at histograms. Between 50 and 60, how many people got a result between 50 and 60? Two, good. So you're reading it off there, yeah? How many got a result between 80 and 90? Three, good. So what was the most common score, or we might say the modal score?
70 to 80.
Yeah, good. So if we look here, 70 to 80 is the highest, so we might call that the modal, we call it the modal category, because it's a category, because we're saying 70 to 80. Okay, so we can see that. Now, can you see when the data has been represented over here in a stem and leaf? When you see the things, so they'll always give you a key, which they've given down here. So the key will tell you what it means. So this is the stem and this is the leaf. So they're saying if you have a stem of 6, it actually means 60, and then the leaf. So if you look at these first two scores, what were these first two scores?
51.
Yeah, good. So if we converted this to a list, it would be 51, 53. What would the next number be?
65.
Good, and so on. What would the highest score be?
96.
96, good. So that's how you can do. Now, I'm just going to, wait a minute, cut this out for a sec. If I take that, can you see that? See if I flip this stem and leaf to that side, can you see how it looks like a histogram? Yes? So it looks like the histogram, doesn't it? And yesterday we talked about the shapes and stuff of histograms. What would that shape look like? Yeah, good. I would say that's symmetric as well. So that's how we're going to look at describing our stem and leaf plot. So if you get a list of data, what we're going to do is we're going to put the stems down here along this side, and then you put the individual scores. Now note that the leaves are in order. And what do I mean by that, do you think? Yeah, good. They're going low to high, aren't they? Like they're in order. See how 83, 84, 87. So you need to put them in order. So what's the advantage of describing in a stem and leaf? The stem and leaf, we can actually see the actual scores, can't we? Yeah, but we can still see the overall trend. So we can see that in the 70s, that was the highest modal category, wasn't it? 70 to 80. So it's similar things. Which graph do you prefer? Actually, I would say in a visual thing, I prefer the histogram. I think if I was going into a company or to talk to my boss or talk about things, I think that the histogram gives a better visual. But it depends on what you want to look at and things like that. Data can always be manipulated to look how you want to see it, and that's why we say all the time. So you'll laugh if the coordinators and all that say some stat coming out, or this year level is all that. You'll see that a lot of the maths teachers will laugh. We could find stats that could go in your favor and make that's the way it works. And so when companies do it, you try to find something that's going to make it look good. Yeah. All right, so let's have a look at these next ones. So a dot plot records the frequency of each category or discrete data value in a set with the thing here. So we can see that the dot plot there. So if you had a list of numbers, so I'll just do an example like that. Say that was my list of numbers. If I was doing a dot plot, I'll put another number there. So what you do is, you do a number line, and then for each data point you put a dot. So you can see we've got something like that. All right. So a dot plot, you can also see the shape as well. It might look symmetric and things like that. Yep. Just going through this stuff. So a stem and leaf plot displays each value in the data using a stem and a leaf. The data are displayed in two parts, a stem and leaf, we know that. The key tells you how to interpret, and the graph is similar to a histogram, but it's just on its side. So you need to be careful with the stem and leaf, because sometimes if you have a number like this, so they say this is the stem, this is the leaf, they might say that this is 1 and 2 and 3. Be careful, because if I say the key, I might say 5.4 actually equals 5.4. Yeah? So that would make these numbers 1.2, 1.3. Yeah? So be careful with that. Make sure you read the key to make sure you know what the numbers are. Okay, so down here, the shape of each of these graphs gives information about the distribution. When they talk about the word distribution, it just means how is it all panned out? What's the shape look? What's it looking like? So before asking you where's the highest category, that's me talking about what's going on, the distribution. So here we can see, can you see that this one has that symmetric shape? If I put a mirror down, they sort of look similar. This one, when you don't have symmetric, we either say it's skewed, and this one, see how it has the thing at the top? This one is positive skewed. And if we had one that went the other way, so it was a tail at the start like that, that will be negative skewed. So they're the shapes. That's the three shapes you need to know. And that's when they say describe the distribution, just describe. Is it symmetric, positive, negative skewed? So let's practice here. For the following data set, organize the data into an ordered stem and leaf plot. Then they want you to describe the distribution of the data as symmetrical or skewed. All right, so we've got a stem and leaf plot. So we're going to draw up our sort of our axes, I guess. Okay, so I'm going to call this the stem, and this is the leaf. Okay, and I'm going to indicate a key. So I'm going to say if I have 2/3, that equals 23. All right, so then I'm going to go. Now, you have to do it in order. What's my lowest one? 22. Okay, so we've got 2, and then we've got a 2, and we'll just cross out that. What's my next highest one? 33, is it? 32. Where's that one? Oh, yeah, there. Okay, so we've got 32. What's the next one? Is 33. So it would be a 3 here. Yeah? And then the next one? 35. A 5 there. What's the next one? We're in the 40s now.
43.
Yep, so a 43, 44, 47, excellent. Then I think we're in 50s, are we? We've got 51, 51, 53, 57, 59. What are we at? 60. 62. 4 and 4. Okay, so just a few things to look out, boys. Make sure your leaves, see how mine are nice like that, because if it's not even, it won't, you can't look at the shape very well. So you've got to make sure that your numbers are all looking, oops. What did I deleted one there. 72. Okay, so boys, it's asked me, let's go. So we've asked to describe the distribution. if we go to look at the shape, so just going to show you again, if I moved this one and flipped it, okay, that's like a histogram. So if we look at the shape of this thing, what do you think it sort of looks like? Yeah, I would say that one is symmetric. So when we comment on this one, we'll say the shape of this distribution appears. We're going to cover ourselves and say the word appears. Yeah? Appears symmetric. So you can sort of say in your eyes that you felt that looked fairly symmetric. All right. Okay, so that is it for today.